Hello, welcome to this video on graphing cube root functions. Today we're going to look at cube root functions and how we transform them with a, h, and k. So for prior knowledge, I want you to go ahead, please pause the video. I want you to just think about this and then describe what are the transformations on this cubic root function. What's a, h, and k, and what are the effects of the graph? All right, hopefully you had a chance to go ahead and identify a, h, and k and the effects. This graph we're going to stretch by a factor of 3, have an x-axis reflection. We're going to the right 6. Remember that your h value is always opposite, and our k value we are going down 1. All right, so let's go ahead and look at the parent function, the cube root of x. So the first thing that I want to talk about that's different than square root functions is that cube root functions have no restrictions on our domain. I can plug in any value into my function. A square root function, I could only plug in 0 or positive numbers, couldn't plug in negative. That doesn't apply with cube root functions. So here are x values that we're going to go ahead and plug into our parent function. And they're chose for us specifically and strategically because they're all cubic roots. So if I go ahead and I plug in -8, the cubic root of -8 is -2. Right? Because -2 times -2 is +4, times -2 is -8. Well, the inverse of that is -2. All right, same question. What's the cubic root of -1? What times itself 3 times gives you -1? Well, that is just -1. The next cubic root value, 0, and I'm going to put it in red because this is our anchor point. And maybe make a note here, anchor point. This is the point that we're going to translate first, and then all the other points hold their relationship to this point. So if I plug in 0, the cubic root of 0 is 0. And here's what I love about the cube root function, or a cubic function, is that they mirror each other. They're symmetric. So +1, if I plug in +1, the cubic root of +1 is +1. And the cubic root of 8 is 2. So really only like 3 values that you need to remember. So we're going to go ahead and plot this. I'm going to draw a y-axis and an x-axis. And I'm just going to plot these points. Again, I'll put my anchor point in red just to kind of help signify the importance of that point. And then this is the way my brain works. I always do the positive values first. I'm going to go right 1, up 1. Then I'm going to go right 8. 1, 2, 3, 4, 5, 6, 7, 8, up 2. Right, again, I don't know if you can see that here. I'll use this mouse. 1, 2, 3, 4, 5, 6, 7, 8 from the anchor point, right? All these are from the anchor point up 2. And now I'm just going to go symmetrically the other direction. So I'm going to go left 1, down 1. And then our last point, going back to my anchor point, left 8. 1, 2, 3, 4, 5, 6, 7, 8, down 2. So those are the key points that we're going to transform today. And then they're just connected with a smooth curve. How do you draw this without it looking ratchet? Here's what you do. Start with your anchor point. And I'm going to go through these points. Smooth curve like that. Almost like it's a square root function. And then I'm going to do the same thing for this other half, the negative half. Start with my anchor point, and I'm going to go through it like this. Notice what it's not. What it's not, I'll use this here in blue. It's not connect dots. Not straight lines. Notice that looks different, right, than the smooth curve. Okay, we're going to go ahead and transform some of these functions. Here are the steps that can help guide you if you forget what to do. We're going to transform those key points that we had, and again, an anchor point, the main point that we'll start with, 0, 0. I would highlight, underline, put a box around that point. Make sure that you know that that is the anchor point. So what we have to do first, find values of A, H, and K. What are the A, the H, and the K? And try to think about the effects. So that will help transform your graph. Step 2, you're going to go ahead and use the key points to graph the parent function, and you're going to apply transformations. What I really want, I want you to go ahead, cross out where it says 4 key points. I want you to just use the anchor point. I just want you to start the anchor point because then we're going to use our understanding of the relationship of the rest of them to get the rest of the points. And then step 3, you're going to graph and draw a smooth curve. You got to be smooth. Okay, let's go ahead and check out an example. So here's the first example. Please write this one down in your notes. And we're going to go ahead and graph this function using transformations. So step 1, what is our A value? Well, A is 1/2. So what are the effects of that? Well, since it's between 0 and 1, it's going to have a compression by a factor of 1/2. So we can expect everything to shrink by a factor of 1/2. Our H value is going to be the opposite. So I know that that is -2, and that we're going to go left 2. Our K value is going to take us down 3. All right, so since cubic functions are very, very wide, what we want to do is be strategic about where we place our x and our y-axis. If I just place my y-axis and my x-axis right down the middle of our graph, when I transform or translate, I'm going to miss, significant parts of my graph. So since I'm going to the left and down, I want that to be more of my center. So I'm going to place my y-axis off to the side. So here's my y-axis. And then my x-axis, I'm going down 3. So maybe I'll place my y-axis up. Also, too, since I have a vertical compression by a factor of 1/2, I'm going to make my scale a little bit wider. So each scale factor will be 1/2. So every 2 will be 1. So there's 1. This will be -1. This will be -2. This will be -3. This will be -4. And I hope that's good enough for my graph. Okay, so I have my x and my y-axis, so let's go ahead and transform our anchor point. Okay, I'm going to go ahead and I'm going to go left 2, down 3 for my anchor point. So 0, 0, I'm going left 2, 1, 2, down 3. Okay, again, I'll use my cursor here. So left 1, 2, down 3. So there's my anchor point. Okay, now if you need to go back to the graph, the parent function, to remember the relationship of these points, you can go ahead and do that. But I'm going to go ahead and start off. Remember, we just go right 1, up 1. from our anchor point, So here I am. Okay, I'm going to go right 1, up 1. But I have a vertical compression factor. So sorry, right 1, up 1 would be here. I have a vertical compression factor by 1/2. So that distance needs to be multiplied by 1/2. So instead of going up 1, I'm going to go up 1/2. Okay, the next point, I'm going to go right 8. 1, 2, 3, 4, 5, 6, 7, 8. And then instead of going up 2, again, I have to multiply 2 by 1/2. I have to take half of it. So I'm going to go up 1 unit. And if you want, you can go ahead and draw an arc through it. Just doing half of step 3 a little early. If you get something weird, if your points, again, look funky, like say here's a point and then you do something like this, like does that look how it's supposed to? No. So that's how you know you have an error. Okay, so it should be a smooth curve. All right, now I'm going to do the other points. Instead of going, okay, so I'm going to go back to my anchor point, and I'm going to go left 1, down 1, right? Symmetrical. Left 1, down 1, which would be here. But instead of going down a full 1, I have to go down 1/2. Again, I'm applying that A value. So left 1, down 1/2. And then I'm back to my anchor point, last point. I'm going to go left 8. 1, 2, 3, 4, 5, 6, 7, 8. My daughter has a toy like that. Counts to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, you guys don't care. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and instead of down 2, I'm going to cut that in half. I'm only going to go down 1 unit, which would be here. Okay, and I'll draw a smooth curve. Ta-da! And there's our beautiful cube root function. It's great. My instructions up here say state the domain and the range using set and interval notation. We already did that lesson in state the end behavior. Domain and range for cube root functions. Do you guys remember what it is? Just, yeah, all real values. Negative infinity to positive infinity. Just a refresher there. All right, so here is a practice problem. Please go ahead, write down this practice problem, graph it using your transformations. So again, identify A, H, and K. You're going to transform that anchor point, and then you will plot the rest of the points using the relationship. If you, again, need to remember what the relationship is with the rest of the points, you can always go back to your parent function notes to see that relationship. My instructions, I don't know if your guys' instructions say this. It says state the domain and the range. If you want to just think about it to keep your mind sharp, you can. And then end behavior, again, if you want to think about it, you can. But that's not the critical skill that we're developing here. Okay, so go ahead, pause the video, give this example a go. All right, hopefully you paused the video and gave this one a go. Here is the solution. So our transformations, we don't have a vertical stretch or compression. Our A value is 1. Those vertical distances do not change. Our H value was a positive 1, and our K value is a positive 3, causing our graph to go right 1, up 3. So from here, you just plot the rest of your values. So I go right 1, up 1, right 8, up 2, left 1, down 1, back to my anchor point, left 8, down 2. So some people like to do to graph that way, the positive values. Other people like to plot the 1, 1, left 1, down 1 once first. I'm going to go ahead and show that kind of method on the next example, and you can choose which one you like. Here is our last example. we're asked to graph the function using transformations. And again, my a value is -2. So this is going to be stretch by 2, as well as a reflection, x-axis reflection. H, remember it's opposite. So +3, that's going to take us left 3. And our k value, +5. We're going up 5. So I'm going to the left and then up. So since I'm going left, I'm going to place my x-axis a little bit to the right. Maybe here. I kind of just counteract my transformations. So into the left. And then since I'm going up, I'm going to place my x-axis down, especially since I have a multiplier. Okay. Oh, and instead of going to the left, this is actually, it's a +3. We go to the right 3. So since I'm going to the right 3, let me move my y-axis. My sincerest apologies to your erasers. And if you are writing in pen right now, I told you so. I told you so. You should use pencil. Pen's okay, actually. But not when you make mistakes. Unless you get the erasable pens. X. Okay. All right. So we're going to go ahead graph our anchor point. So from 0, 0, I'm going to go right 3. 1, 2, 3, up 5. 1, 2, 3, 4, 5. So there we go. I hope I have enough room. 1, 2, 3, 4, 5, 6, 7, 8. Oh no, I'm off 1. I'm going to erase this again. I'm going to place my y-axis here. Okay. So right 3. So 1, 2, 3, up 5. 1, 2, 3, 4, 5. Okay, so here's my anchor point. I had to count twice, 2 different screens. Okay, and now I'm going to go ahead and plot my other points. So last example, I did the positives, right 1, up 1, right 8, up 2. This time I'm going to do the right 1, up 1. I'll do my ones, I call them. Right 1, up 1. Instead of going up 1, my multiplier is -2. So instead of going up 1, I'm going to go down 2. I just multiply that distance by my a value, -2. Okay, now the other 1 is left 1, down 1. Right? Normally we go left 1, down 1. But again, instead of going down 1, I have to multiply that by my a value, which is -2. So instead of going down 1, I'm going to go up 2. Okay, back to my anchor point. Now I'm going to do my 8s. So I go right 8, 1, 2, 3, 4, 5, 6, 7, 8. And then instead of going up 2, again, my a value is -2, so I have to multiply, and I get down 4, right? +2 times -2 is -4. So 1, 2, 3, 4. And again, if you couldn't see that, here's what I did. I went right 8, 1, 2, 3, 4, 5, 6, 7, 8. And instead of going up 2, I went down 4. 1, 2, 3, 4. Okay. And then lastly, I'm going to go left 8. 1, 2, 3, 4, 5, 6, 7, 8. And instead of down 2, I go up 4 because of my a value. 1, 2, 3, 4. And again on the screen so you can see. 1, 2, 3, 4, 5, 6, 7, 8. Up, 1, 2, 3, 4. Okay, so now I just need a smooth curve. And again, I recommend drawing 2 pieces from your origin. So there is your cube root function. All right, here is your last practice problem. Give this one a go. Pause the video. Remember, identify A, H, and K. And then graph the rest of the points. All right, hopefully you had time to pause the video and give that example a go. Here is the solution. A common question and problem for students is, where do I put my X and my Y axis, like when you're given a blank grid? Again, I want to see kind of where the central part of the graph, because a cubic function just goes on forever. You know, if you're not centered right, you don't see the significant or the important part of the graph. So like in this example, here our H value is -6. We're going to the left 6. So if this is like my center, normally I would center my graph here. I'm going to go to the left 6. I'm going to go, my graph's going to shift to the left 6. So I'm going to counteract that with my X and Y axis. I'm going to go to the right 6. 1, 2, 3, 4, 5, 6. I'm going to place my Y axis here. And then the same with my K value. My K value is down 4. So I'm going to do the opposite. Oh, let me write down 4. I'm going down 4. So I'm going to shift my x-axis up 4. 1, 2, 3. And put it, oh, that was really rough. But that way, watch this. Now that when I go to plot my anchor point, I go left 6, 1, 2, 3, 4, 5, 6, down 4. 1, 2, 3, 4. And hey, there's the central part of my graph. So that's kind of the technique when you have to plot your X and Y axis that I'm using here. So we also had a value that's -2. So I'm going to reflect -2. And it's also going to compress by 1/2. All right. Closure. Why is the domain the set of all real numbers for the cubic root function? Think about that. I'll show the response in a second. Okay, here is the answer. The domain of f of x is the set of all real numbers because the cube root of negative numbers, 0 and positive numbers, are all real numbers. There's no need for these values to be excluded from the domain. All right, I hope you learned how to graph cube root functions in this video. Catch you next time. Be safe, be easy. Peace.